Hello everyone, welcome to Newton's Spectra Extramural Academy channel. So today we are going to discuss one of the branches of physics called mechanics. And today we are going to derive the equation of motion. The equation of motion, linear motion to be specific. Now before we proceed, let's quickly talk about the parameters needed in deriving the equation of motion. The acceleration is denoted by letter A, distance is denoted by letter S, velocity is denoted by letter V, time is denoted by letter T, speed is denoted by small letter v, displacement is denoted by d or x. Now, this illustration here shows the movement of car from point A to point B on a straight line. When the car is at rest, then our u will be equals to 0. That is the initial velocity. Now, what is acceleration? Acceleration is the rate of change of velocity with time. It is denoted by letter A. It is measured in meter per second square. Mathematically, acceleration equals to v minus u over t, where v is the final velocity and u is the initial velocity and our t is the time taken. Distance is the gap between any 2 points in space. It is denoted by letter S, measured in meter. Mathematically, distance equals to average speed with time, where our average speed is open bracket v plus u close bracket divided by 2, and we have our time. Now, velocity. Velocity is the rate of change of displacement with time. It is measured in meter per seconds. Mathematically, we can express velocity as displacement over time taken. And our time is the duration of an event, measured in minutes or seconds. Speed is the rate at which a body covered a distance. Our speed is the rate at which a body covered a distance, measured in meter per seconds. Mathematically, speed equals to distance over time taken. Now, displacement. Displacement is the distance traveled in a specific direction. It is measured in meter as well. Displacement equals to velocity times time, equals to velocity with time. Average speed. Average speed is the total distance covered with time. It is measured in meter per seconds, and our average speed equals to distance over time taken. Now let's derive the equation of motion, equation 1. So we recall that acceleration equals to v minus u over t. So in this case now, we cross multiply. So we'll be having v minus u equals to at. Now the next thing we need to do is to make v the subject of the formula. So we'll be having v equals to u plus at. Don't forget, when minus cross the border of equality sign, it's going to change to plus, and when plus cross the border, it's going to change to minus. So therefore, v minus u plus at, that is our equation 1. Now, let's derive equation 2. Equation 2. So we recall that our distance equals to average speed with time, where average speed equals to v plus u over 2 close bracket t. Therefore, we'll be having s equals to v plus u over 2 close bracket t. Now we take this as equation 2. Equation 3. So we recall that v equals to u plus at and s equals to v plus u over 2 close bracket t. So what we need to do next is to substitute. We say substitute v into equation 2. So when we substitute v into equation 2, we'll be having s equals to, my v now is u plus at plus u close bracket t divided by 2. Now in this case now, let's open the bracket with our t. S equals to u times t will give me ut plus at times t will give me at square plus u times t will give me ut divided by 2. So next thing I need to do is to rearrange. So I will be having ut plus at square divided by 2. So I have s equals to 2ut plus at square divided by 2. So in this case, I can cross multiply and I have 2s equals to 2ut plus at square. Now to get rid of this 2 here, to get rid of our 2 here, all I need to do is to what? I will divide both sides. Divide both sides by 2. Or I divide through by 2. So I have 2s divided by 2 equals to 2ut divided by 2 plus at square divided by 2. Now 2 will cancel out 2 here. So we have s equals to ut plus at square divided by 2. And I can rewrite this as s equals to ut plus 1 over 2 at square. This is my equation 3. Now to derive the fourth equation of motion, we need to recall again. Recall that v equals to u plus at and s equals to v plus u over 2 close bracket t. Now from equation 1, let's make t the subject of the formula. So we're having v equals to u plus at. Now we'll be having v minus u equals to at. I divide both sides by a, so I can get rid of the a. So I have t equals to v minus u over a. Now, the next thing I will do, I will substitute t into my equation 2 here. Now, I have s equals to v plus u over 2. What is our t here? V minus u over a. So we put our multiplication sign. Now let's multiply. We have s equals to v times u will give me v square. V times minus u will give me minus uv. Now, plus u times v will give me plus uv. Plus u times minus u will give me minus u square. Everything divided by 2a. So let's rearrange. We have s equals to v square plus uv minus uv minus u square. Everything over 2a. So we'll be having s equals to v square plus uv minus uv will give me 0 minus u square divided by 2a. So the next thing I'll be having now is s equals to v square minus u square over 2a. So here we cross multiply. So we'll be having 2as equals to v square minus u square. Now let's make v square the subject of the formula. So we have v square equals to u square plus 2as. So this is our fourth equation of motion. This is how to derive the fourth equation of motion. So in our next class, we're going to apply all the equations derived in solving some problem in physics. See you in the next class. Thank you.